Welcome to this AB Lab on bioeconomy. I would love to welcome here on stage with me Steven Ware. Steven is architect partner at Art and Build, but is also trained as a biologist. Welcome, Steven.
Thank you very much, Sunita.
And we also would like to welcome with us Professor Michael Braungart with us through a video conference. Michael is a chemist and is founder of EPEA, but also mostly famous for his ideas and books on the cradle-to-cradle approach. Steven, could you explain to us what is bioeconomy?
Well, the bioeconomy could be considered as a subset of the circular economy. The circular economy is a paradigm which looks to render industry, our activities as a culture, as a global culture, to render those activities more efficient, to use less energy, to think about the future of materials and not just their application for one use alone. It is how to be more responsible with the way in which we prescribe, which we extract, and in the way in which we upcycle these materials. So the bioeconomy looks more specifically at materials coming from life cycles, so things that come from growing plants or growing all the species which we commonly use right now to nourish ourselves, to feed ourselves, to heal ourselves, and to protect ourselves, whether it's clothing or buildings. So it's a very specific aspect of the circular economy which looks particularly at how we can use living cycles and living production mechanisms in order to enrich the way in which we build and the way in which we design.
There are some amazing technologies now arising in building manufacturers. Could you maybe elaborate a bit, or maybe even think about the possibility for cradle-to-cradle robots?
When you think about different business models, but it still takes time that people understand the opportunities. I was at a southern German car manufacturer, and can you imagine, they buy 200 robots, but nobody needs a robot. You need the service of using it. So instead of buying 100 million welding points, they buy robots. So they're stuck with it, and they have to pay for maintenance and reprogramming and all the stuff with it. And in this context, it makes far more sense to sell just the service of using a robot. Then you can use far better robots as well at a much lower price.
In your regard, it's mainly indeed about the services. Can you also give maybe an example of a new technology in buildings with regards to the cradle-to-cradle approach? What's your main trend that you see there?
Donald Trump is a much more honest liar than we are. Yeah. So there was never a car recycled into a car. There was never a glass of a window ever recycled into a window glass again. There was never a mobile phone recycled into a mobile phone. So the existing stuff is amazingly primitive when it comes to true circular economy. Why don't you just buy 30 years of insulation and looking through insurance instead of buying a window? So this is where we always use the cheapest materials instead of using the best ones. And this means different business models first with our existing stuff. But when you look from a different business opportunity, you can come up with completely different options and different solutions.
The nature of the living world outside the human world, if we could make a definition, doesn't talk about ownership. You know, materials transfer from one organism, from one species, from one kingdom to another quite fluidly. In the models, the economical models which we apply to the auto industry, to the building industry, we tend to think about the ownership of the material. And I think that what Michael is referring to is to rethink that model, that whole paradigm, so that we don't see a building as simply a collection of materials which somebody owns and doesn't think about what it's going to become, but you become a library of materials which can then be disseminated, which can then be transformed into something at the end of its life. But that means thinking about the end of its life. How long will this thing last? We tend to think now about automobiles as having more or less a certain lifespan. We certainly consume them much faster than we consume buildings. We still tend to want to believe that our buildings will last forever. Certainly as architects, we think that if we do a good job, our building will last forever. So we don't integrate this notion of materials and recyclability, or even better, upcyclability of the materials, which may have more value in 20 years' time than they have right now.
How can you see a link between indeed materials for buildings and other manufacturer companies?
So first of all, you cannot separate that because look, for example, a Mercedes-Benz has 46 different steel alloys. Yeah, and there was never a car recycled into a car. That means we call it recycling when we use high quality steel from vehicles to make building steel out of it. So we lose all the trace metals like chromium, nickel, cobalt, manganese, copper, all gets diluted in the steel and we lose it. And we call this recycling, and it ends up in concrete steel. This is why you need to see the whole system, not just the building part, but you need to see how we do material management per se, because otherwise we are causing bigger problems somewhere else. This means we need to first look for a building to say what is a building which is healthy for people.
We do a lot of timber buildings. Yves Weinand also does a lot of timber buildings. And there has been a concern which has been raised often about the COVs, about the fine particles, about the different emissions, the chemical emissions that wood has. One of the main problems is that we don't define the good emissions and the bad emissions. There are emissions which are coming from glues, and there are good emissions which come naturally from wood, which we've lived with ever since our species started to live in huts made of wood. So the main problem is closing the buildings off, just as Michael said. If you close the building off, you trap all of those things, and then it becomes a problem. If you integrate the proper ventilation and you make sure that the filters are cleaned, you have absolutely no problem at all. So we have to not only deal with the materials that we're sourcing and where they come from, the bioeconomy, coming from the living, something we've already accustomed to living with, and separating the good from the bad and not throwing out the baby with the bathwater. Another aspect, again, which Michael was referring to is the way in which we consume and then we throw away. That can be the same with carpets, which have a very high turnover. It's also the same with technical floors. Technical floors is a big problem because when you say, there's a building being demolished next to me, I'm going to take the technical floor, I'm going to put it into my new building. Exactly. Immediately, the insurance company will come along and say, no, not possible. You have to buy a new one. I'm not going to guarantee, So there's an aspect of the economical ability or the legal value of what you do, which doesn't follow the ability to share materials from one building to another. So in fact, the city is isolated. The elements are isolated one from another. They can't do what trees do, share carbon. Buildings can't share things. It has to be one independent entity which survives on its own, which has to incorporate resources on its own, and that's a very inefficient model for a city. The inability to share things between buildings, between its empirical components.
Traditionally, people think about efficiency. Mm-hmm. That means they are optimizing the existing stuff. Yeah. It means doing things right. So this is why I say, hey, let's first talk about what is the right thing. This is coming back to my colleague. Yeah, let's think about a building like a tree. This tree is not efficient, but effective. Look at a cherry tree in spring. It doesn't reduce, avoid, minimize, but all the materials are designed to go back into the biosphere. But we do not want to have just compostable stuff. We need computers and washing machines. This is why there are two different spaces, the technosphere and the biosphere. But in this context, we can make buildings like my colleague mentioned in a way that they support each other, not just seeing them isolated, like a tree supports the other trees as well. Yeah. So let's make buildings which clean the air, buildings which absorb water, which protect from stormwater, buildings which are beneficial instead of just a little less bad. Because from less bad, we are far too many people on this planet. It has to do that we think we are protecting the environment if we are minimizing damage.
This is with regard to indeed materials. What would you say about upcycling of sewage systems, water systems? What are your ideas about those elements?
Well, first of all, you can see that we are in a very terrible situation when it comes to our role on this planet. We think it's better if we are not here. Yeah? Take the definition of sustainability to meet the needs of the present generation without compromising the needs of the future generation. Isn't that perverse? Think about you come home and you tell your children that you don't want to compromise their needs. Yeah? Don't you want to be good for your children? Yeah. So it has to do with our religion, whether it's Christian or Islamic, it doesn't matter in this case. Religion tells us you are evil and only God can redeem you. This is why we only can be less bad. We cannot be good. Yeah. So a city like Brussels wants to be climate neutral.
One of the very interesting things that catalyzed the whole movement towards the circular economy, and that came from the ideas, some of the fundamental ideas in Cradle to Cradle, was we should not think about waste anymore. You know, everything becomes the nutrient for another system which is next to it. It's much easier when we talk about the bioeconomy to go looking for materials which come from natural cycles and to use those. If we could build wooden cars, that would be wonderful. If we could build wooden buildings, well, we can now, and it's getting much more easily, that would be wonderful, because it's less difficult to find an upcycle, to find a way in which those materials can become nutrients for the next cycle, the third life of the tree. First life of the tree, the forest, second life, the building, the third life, what is that going to be? We can imagine that quite easily when it's a tree, because in a way we know the design chemistry of the tree, and that fits in with the biological cycle.
And you've been indeed speaking about wood. What are other elements from nature that we could use in our building systems?
There's flax, there's hemp. I mean, there are an enormous number of plants which can be used. I mean, there are bamboos, there are all sorts of things that can be used for structural purposes. We just have to scale them up. You know, industry has to scale them up, and we have to look at what they can do, pass them through the same filters that the building industry has used for the development of steel and concrete. You know, you make mistakes. Right now we've got such a challenge against time that we're going to have to take a few risks. And that's not easy for the building sector, for the general public to accept. Fire is one of them. We're very, very afraid of fire. I think even in the 1970s, there was a film that came out in Hollywood, The Towering Inferno or something like that. That stopped all high-rise buildings being built for the next 10 years in the city of Paris. When we have a building that goes up in flames, that stops anybody wanting to build in timber, which is kind of ridiculous, because timber buildings are no more fragile from a fire point of view than concrete buildings are. So we have to resist this sort of public temptation, or this general sort of psychological temptation to drift towards things as a knee-jerk reaction.
Why don't we celebrate a human footprint instead of minimizing it? Yeah. Why don't we see humans as an opportunity for the planet instead of trying to minimize their impact? For being less bad, we have far too many people on this planet. This is why we need to eliminate the idea, the concept of waste. All the other species don't make waste. Why are we more stupid than all the other species on this planet?
Yeah, I think this mindset is very important. To move on to another mindset is very important. Part of this mindset is the idea that we have cities and we have the countryside, or we have cities and then we have nature, and that these two are independent entities. The city needs nature to produce oxygen, to produce its food, and that the countryside somehow needs governance from the city. Or we have these two poles, and this is a mindset which has to change as well. The city can become a harbor for biodiversity. It's a different biodiversity from the one that we will see in the forests when we go far away. The city can also stock carbon. It can sequester carbon with timber buildings. The city can become an entirely different model of an ecosystem, which is which is stable, because that's what ecosystems do. They have amazing mechanisms in order to find stability. They can do that, and in the same way, forests can also become productive. We don't have to simply, put a glass dome over them and say they have to be protected for what they are. They need to be in contact with a lot of moving things, whether it's the birds migrating. They need to be in contact, but they also have to become productive in their own right and become richer in a way in their ability to combine with human beings' demand. So we have to work on those two models as potentials for development in their own right. As architects, we tend to focus on cities. That's natural. That's where all the building happen. But what we want to design is an ecosystem which is the city, which does all of those things which previously we expected nature to do somewhere beyond the walls of the city. That mindset has to change. There is no one building which really goes all the way down the line and connects all of those points together and measures all of the impacts, but that is the ultimate goal. Biologists think in terms of scale in a way that the common person thinks of scale now. They have three scales, time scales. They have the biochemical, which is ultra fast, imperceptible to us. Then they have the organismic, which is the number of times we bat our eyelids or our heart beats and we breathe, we talk. And then there is the evolutionary, which escapes us because we're talking about millions of years. Biology it manages to stitch those three scales together in its way of becoming stable, creating stable ecosystems and evolving, innovating, becoming more adaptable to a different situation. For us, it's extremely difficult to take buildings which are so much in the domain of our own particular human timescale, our organismic timescale. We don't think about the long-term impacts of what it is that our buildings are going to be or our cities are going to be in that sense. And so they're inevitably they're not resilient.
So a big challenge indeed for architects to make those prototypes and learn from each challenge. Michael, thank you very much for this interesting conversation. And thank you, Steven, also for those challenging talks.
You're welcome.